We are going to do one full hypothesis test right now, and we are told that the average resting heart rate is 65 beats per minute for everybody. We sample 50 athletes. In case you're wondering, we're going to do randomly sample 50 athletes, and the resting heart rate was 57.3. Do athletes' hearts beat slower than average? So let's start us out with our population. Our population, all athletes. Our parameter, mu equals average heart rate of athletes. So our null hypothesis is that they're just like everybody else, which means we are going to go with 65. The alternative is, since it says slower, less than 65. Whenever they don't give me an alpha, I normally use 0.05 unless I have a reason to use 10% or 1%. And this is a one sample Z hypothesis test. Number 2, conditions. SRS stated. Independence. Well, we have 50 athletes times 10 is 500, which is less than the total number of athletes. And for normality, we got 50, which is bigger than 30, which means the central limit theorem says that this is approximately normal. 3, our calculations. So I make my normal curve. Mu of x bar equals 65. Sigma equals something divided by the square root of 50, which is 13. And x bar was 57.3. So this turned out to be 1.8, which means this is way down here. And there's just going to be a little bit. And this is one-sided because we went less than. So Z equals 57.3 minus 65 divided by 13 over the square root of 50. Which means our Z-score is negative 4.18. The probability that Z is less than negative 4.18 by using my normal CDF, negative really big number to negative 4.18, is pretty much 0, 1.4 times 10 to the negative fifth, which is certainly less than 0.05, which leads me to number 4, which is our conclusion. Since we have a low p number, I reject the null hypothesis. I have evidence to suggest that athletes mean heart rate is less than 65. And that is one hypothesis test. Now, the only thing that I want to show you, I don't want to go through a whole other problem, but if the alternate hypothesis was in a situation where we had mu is not equal to 65, everything else would stay the same except for we would multiply this number right here by 2, and we would wind up with 2.8 times 10 to the negative fourth, which would be my p-value, and we would have done p is less than or p is greater than, I'm sorry, not p, z is greater than 4.18, and we would still reject, but instead of less, I would have said different. So all of the stuff that's in green is what would have happened if we had a situation where we were doing something that was two-sided instead of one-sided.